Hey everyone, and welcome back. Now today I'm going to be doing something a little bit different on the channel just because I actually did a poll probably several weeks, maybe about a month or so back, basically asking if people would find having more basic information about blockchain and crypto and kind of how some of this type of stuff works, if they would find that useful or not. And this has been something that I was kind of considering doing anyway, just because I've been a little bit surprised with how many people are in crypto, just how many don't really understand how a lot of this stuff works kind of at like a base level. And again, maybe while you don't necessarily need to understand this, it's something that I definitely think does kind of help getting a better grasp on just the entire industry, how it works, why it works, some of the problems that we're facing, why they're problems, how they're problems, things like that. And so ultimately this is something that I want to prepare kind of for two reasons. One, to just kind of educate people who are already in crypto, but also if you're anything like me, you probably have a lot of people in real life that either have very limited or no exposure to crypto at all. And so this is something that I kind of wanted to make as kind of a place that you could point people to as kind of like hey, if you know nothing about crypto, here's kind of a place where you could start and maybe learn some of the more basic things about crypto generally. So the thing I want to start talking about is blockchain, because blockchain is kind of what started it all. And this is kind of the whole entire foundation that the entire crypto space is based on. We are starting to see some deviations and some moving away from the kind of the more traditional blockchain model. But I mean, that's an issue for a future date. Currently, blockchain is kind of everything and kind of the majority of what's going on right now. And so I feel like it makes sense to talk about it. So without further ado, let's go on ahead and dive right in, and we can start learning about how does blockchain actually work. All right. And so this is something that, it's not that complicated, but kind of some of the nuances to how and why it works is really important. And because a lot of people and a lot of the questions that I hear kind of at the base level is like, well, how can I trust, like, I'll probably use Bitcoin as kind of the primary example today, just because it's the one that people know. But I'll hear a lot of times like, well, how can I trust that like Bitcoin isn't going to get hacked, right? Like, I know that I can trust my bank account, sort of. I know that I can trust my bank account because I have my own username and password, and only I know my username and password. And so people don't know how much money I have. They don't know how to send me money or take money from my account, anything like that. But on the blockchain, everything is open sourced. We can go and see that Satoshi's wallet has 1 million Bitcoin in it, right? Like that is something that is possible for us to see. And so I think for a lot of people who don't understand the nuances of crypto and blockchain specifically, that kind of causes some level of worry of like, well, if people know where my money is and how much I have, why don't they just take it? And so we're going to discuss kind of why that's not possible, and also some of these like transactions being immutable, right? We've talked about transactions being immutable before. How does that work? Why does that work? How can I just not go change a transaction on the blockchain? And we're going to talk about that as well. So first off, what is blockchain? So blockchain is a digital ledger consisting of blocks that essentially are linked together using cryptography. So we'll discuss kind of what the cryptography piece of that is, but ultimately, I mean, that's just it, right? Like, it's a ledger that tracks, okay, well, this is what happened here. Okay, well, now this is the next set of transactions that happened. Okay, now this is the third set of transactions that happened, so on, so on and so forth. We'll get to some graphics visualizing this here in a second. All of these blockchains use cryptography, and cryptography usually requires a hashing algorithm. The SHA-256 hashing algorithm is one of those. There are several different hashing algorithms, but Bitcoin uses the SHA-256 hashing algorithm. So we'll dive into this a little bit further, but I mean, you don't have to use this one. This is just what Bitcoin uses. Ethereum uses ETH hash. There's a whole bunch of different types of hashing algorithms that you can use. Hashing has two very important characteristics that really are kind of the foundation of cryptography and therefore blockchain at its core. First one, minor changes to data result in major changes in the output, i.e. an avalanche effect. This is something that is really important because, if you want to go change a decimal in something, like, it's not going to minorly change the hash that comes out of it. It's actually you're going to get a completely new different hash. We're actually going to look at this here in a second. The second one is it's irreversible. So what this means is essentially it can't be reverse engineered, right? Because if I essentially know how a hash is created, then I know what I can do to essentially force the hash to say what I want it to say, right? And if that was possible, then this hashing algorithm would no longer work, just because now people would know essentially how to game the hash or game the system and come up with hashes that are beneficial for what they're trying to do. So that's kind of why these two things are kind of the crux of what we're looking at. So in order to explain this, I wanted to move over to this website. It's called Code Beautify, and they actually have, you can see, I was talking about earlier how there's a whole bunch of different hashing algorithms. Here's like 30 right here, right? So what I've gone to is I've gone to the SHA-256 hash generator, and I've put in kind of like a base example or very bare bones example of generally how this would work. And so what we can see is in a blockchain, this is typically what you're getting. So in the block, you're going to have the previous hash of the previous block. You're going to have the timestamp. You're also going to have the transactions within this block, and then that is going to give you a hash that is then going to essentially become this piece. And so what we can see here is we can see a couple of different things. So one, if we try and change this hash, let's just say we get rid of this 8. If we look at the hash down here, the output hash, it starts with 2B9F. Okay, well now it's 0B5C. So I mean, it's not even completely different, or it's not even close to the same thing. And now if we look, we're 2B9F again. Now let's just change it from an 8 to a 7. Only changing one number. Oh, now we're 1E75, right? So these changes, even though somewhat minor within this system, result in completely different hashes, which is kind of the whole point. Same type of thing here. Let's say, Ginny pays Johnny 1.5 Bitcoin. Well, let's just say I'm Johnny and I'd rather get 15 instead of 1.5. So if I'm Johnny, I'm going to come in and change this. Oh, but we can't, because we're going to get an entirely different generated hash. Same thing, like let's say I come in and I'm like, oh, well, nobody's paying Cade. Let's have John pay Cade instead of Jane. Nope, we can't, because it results in an entirely different hash, and I have no idea how or why this hash is being generated the way that it is. So that's kind of the core tenets as to how the hashing algorithms work and why they keep the chain secure. So moving back to the slide, that is essentially how hashing works and how we can get hashing, or how hashing keeps the blockchain secure, right? So now we need to go into, well, what happens within each block and how does the blockchain essentially become a chain rather than just a bunch of blocks. Each block contains 3 steps. Now, the first one is a cryptographic hash of the previous block, which we talked about in the example using kind of the hash generator algorithm. The second is the timestamp, which is the time that the block was actually minted. And then the third one is the transaction data. The thing that makes this a chain is the cryptographic hash from the previous block, because if you didn't have that, there's nothing really connecting the previous block to the next, and so on and so forth. Also, there's 2 major characteristics when we're going over blockchain. The cryptographic hashing is essential, right? We need to have that, because without this, we cannot have the security guarantee, because the cryptographic hashing is something that essentially we need for, at least in proof of work, we need this to be able to kind of keep security within the system. Well, that's kind of the first piece. The second piece is distributing the ledger so we can have the public access. That also enhances security, because if you're giving the same ledger to everybody and then somebody comes up showing a different value, okay, well now you've got a problem, right? But it's pretty easy if you've distributed this to 1,000 people, because then now 999 people have the same outcome, where one person only has a different one. Or if you only distribute it to 2, well, which one do you believe, right? So I've got another example showing kind of how this works. So let's go over and take a look at that as well. So here we can see that this is a blockchain demo, which is actually really cool, and it shows exactly kind of how this works. So each block, I've already got 3 blocks minted. So we've got the Genesis block. This is essentially like the first block, and we're going through, and everything after this is kind of the chain, right? And so every blockchain has a Genesis block. Sometimes it has data, sometimes it's hello world, sometimes it's nothing. It just really depends. But we can see the previous hash is 0 because there was no previous hash. We've got the data in here, and then now we've got the hash as well as the timestamp. Now here in block 1, we've got the data. We'll just say it's K, I get 10 of whatever we're minting here on this block. We can see the previous hash matches this hash. We also have the output hash from this block, including the timestamp. And we can see it took us 331 attempts for us to find a hash that actually fits within the criteria. And currently the criteria is it must have 3 zeros. any hash that has 3 zeros is fine, but it has to have 3 zeros. So we can see here it took us 331 attempts for us to find a hash using the criteria of finding 3 zeros. Now you might guess, well, okay, well, we've got the time, we've got the data, we've got the hash. How do we solve for this, right? Now there's two ways. So one way is, in Bitcoin specifically, you have something that's called a mempool, right? And the mempool is essentially pending transactions that have not cleared yet. And so one way that you can play around with this hash is changing the transaction data within the mempool. So, instead of Cade having 10, maybe you put in, John having 5, if that's or John sending Doug 5, because that's in the mempool. If this is something where, there's no activity on the block and the only thing is that Cade is getting 10 because he's minted the block, you also have a nonce, which is, it's called a number only used once, and it's essentially a plug number that you can change really quickly to essentially try and force different hashes that give you this 000 number. This is why blockchain is very important, is because it's the proof of work, right? At least within Bitcoin and some other some other blockchains, they need proof of work. And so you're proving that you found something that fit this criteria, right? Now, if we wanted to make this harder, just increase the number of zeros. If we increase the number of zeros, it's going to become harder to find a hash that has, 8 zeros instead of 3. So what we can see here is this chain actually works, right? Now, let's say I'm Cade, obviously. Now, I want to give myself 15 instead of 10. Well, oops, I've now screwed up the entire blockchain. And so now what I have to do is I have to go through and recalculate all of these blocks before the next block is mined, right? So we go through here. This one took 382 tries to find a hash. This one took 430 tries. And this one took 2,400 tries. Now, keep in mind, this is meant to be a very, very easy example of what's going on here. Usually to mine one of these blocks, at least on Bitcoin, it auto adjusts, so it takes about 10 minutes for that to happen. Here, obviously, this took me a total of 5 seconds. Usually it's trillions and quadrillions and quintillions and upwards of attempts that it needs in order to actually find the solution for one of these blocks. And so that's ultimately kind of what we can hang our hat on here, is that we're essentially hoping that the entire ecosystem can find the solution to one block before I have the ability to find the solution to 4, and then also push that out to over half of the network. So that's kind of how the security guarantee is provided here. Same type of thing if we want to add a new block. Let's say Jane gets 10. Add a new block. We can see same thing in here. We've added the previous hash. Now we have a new hash, and this is what keeps the blockchain going on and on and on. So that's essentially kind of a quick and dirty way of how a blockchain works. Now we'll head back to the presentation. So the last thing that I want to show you is just a couple of graphs that discuss more about the consensus mechanism, because now we've seen essentially how the block time or the block chain itself works. Now we're looking at, well, how do we get consensus around it, right? And so what happens with this is generally we can see we have a distributed ledger. Each ledger has a copy of the blockchain, and these are all talking to each other, and they're essentially comparing notes and making sure that everybody has the same blockchain. And we can see, we've already been over this. We've got the block hash, timestamp data, all this type of stuff. But what we can see is now, let's say a new block is mined. Well, now we're going to essentially send this new chain out to everybody, and they're going to verify, okay, well, is the previous hash right? Is the timestamp, is the date, is everything previously good, or everything previously happening right? Okay, and essentially what we're doing is we're giving them the answer to the problem, right? Here's the block number, here's the new previous hash, because we now are at a new block. We've got the new timestamp and the new data. Do we get a hash that fits the hashing algorithm for that particular blockchain? If the answer is yes, okay, great. We've added a block to this chain. Now it's time to solve for the next one. And we essentially just go on and on and on all the way through it until that happens. And so this is essentially kind of how that works. And when somebody finds a new solution, they send it out to everybody in the network. The network compares notes, make sure that the answer is valid, and then they go from there. So that's essentially kind of how the consensus mechanism works. Next, I want to talk about just kind of like a step start to finish, just to kind of wrap it all up and put it all together. So how a blockchain works is essentially to transmit stuff, information, right? And so first off, we're going to see that a transaction or some sort of on-chain activity is requested. We're going to create a block that represents that transaction. Now, the block, obviously, we've been over how the block is created. It's by finding a solution to the hashing algorithm. Once that solution is found, the block is sent to every node in the network, essentially to say, hey, I found a solution to this most recent problem. Now let's carry on. All the nodes in the network now then validate, yes, okay, you actually did find a valid solution. Now we're going to move on to the next block. The person who found that solution, or the node that found that solution, will receive a reward for the proof of work that they actually found a valid block within that transaction. Now that block is added to the existing blockchain, and the transaction is complete. And then we start all over again whenever new transactions are requested. So that is essentially how a blockchain works in a nutshell. Hopefully this information was useful. If you have any questions, comments, concerns, anything, you have other maybe questions of things I didn't cover, or specific questions of things you'd like me to cover in the future, please do feel free to add those in the comment section below. This is more basically just meant to be kind of me sharing some information of what are some more, I would say, relatively basic, like kind of foundational concepts within the crypto space. And so if there is anything that you feel like I could have explained better, or maybe I left out, or you have maybe some, something that you want clarification on, please do let me know. Obviously that is kind of the whole point of this video. And so if there's something that's confusing or you're not understanding, obviously, I'd like to clarify that and make sure that I either edit, this in a future video, or just make sure that I clarify it as I continue moving along. I am planning on kind of building on this foundation. As I've mentioned, blockchain is kind of the foundation that everything sits on. And so from here, we'll probably look at coins, tokens, NFTs, smart contracts, dApps, all this other type of stuff. But right now I kind of wanted to set the foundation of what is a blockchain, how does it work, all of that type of stuff. So again, like I said, hopefully this was useful. If it was, please do give me a like and subscribe. It really does help me out, as well as help me grow the channel. Also, like I said, anything else that you want to comment or add to, I would really appreciate it. Thank you all for tuning in, and we'll see you in the next video.